Welcome to the video. I am Prerequisites from MATLAB Helper, and in this video we are going to develop a program to perform face recognition in your smartphone using MATLAB Mobile. Our face recognition program is developed by using transfer learning using AlexNet. AlexNet is a convolutional neural network that can classify up to 1,000 objects. What we do in our program is implement transfer learning using AlexNet and change the 23rd and 25th layer of AlexNet to classify images based on our desire by training it using transfer learning. The flow of the program will look something like this. The prerequisites for this program are: 1. You must have the deep learning toolbox along with the AlexNet support package installed in your current MATLAB version. 2. You must have the MATLAB mobile app installed on your smartphone. 3. You must have the MATLAB drive setup and synced. In the first program, we are going to capture images of the faces we want to recognize and store it in the form of a database. We then create an object M which is used to retrieve sensor data from our smartphone. Then we use the camera function to retrieve video data from our smartphone. Then we use the vision.cascade object detector, which uses the Euler-Jones algorithm to detect objects in an image. Then we assign a variable C, which is set to the value 50, which determines the number of images for each individual in the database. However, it is recommended to capture 100 to 1000 images for each individual to improve the accuracy of the neural network which we are going to train. We then use a while loop to capture and store images. We use the snapshot property of cam to take pictures from the live video stream. We then use the face detector system object and pass the parameter pic and store it onto a variable bbox. This creates a bounding box around the face in the pic by calling the system object face detector. The above step returns an m×4 matrix bbox that defines m bounding boxes containing the detected objects. In simple terms, it returns a matrix that contains the dimensions of the bounding boxes around the face detected. Then, if the sum of the bbox matrix is not 0, then the face is detected. We then crop the image to the bounding values we have just determined. Then we resize the whole image using the imResize function to resize the image to 227 x 227 to match the input size of AlexNet. Let us now run this program on our smartphone. We will now run the same program on MATLAB Mobile on our smartphone. We will first be creating a database of Mark Zuckerberg. We are going to be taking 50 photos of each of the individuals. If we go back to the MATLAB drive, we see that the images are numbered from 0 to 49, and we have a total of 50 images, and this is what a sample image looks like. Then we store all of these images into one folder called Mark Zuckerberg. We repeat the same steps and capture images for 3 other individuals, namely Donald Trump, J.K. Rowling, and myself, Prerequisites. We then create a folder called Image Database, and we move all these folders into this main database. It will be more convenient to handle the drive on MATLAB desktop. Hence, we have done all the database handling in MATLAB desktop. We then go to the next part of the code. In this part of the program, we are going to train our neural network to recognize faces using transfer learning. We load AlexNet onto a variable called net. We then extract the layers property of AlexNet and store it to a variable layers. Let us run this code. We can also analyze the network using the analyze network function. We see that AlexNet has total of 25 layers. We can make use of the MATLAB documentation to help us in our program. We see that the last 3 layers of the pre-trained network are configured for 1000 classes. Hence, we have to change these last 3 layers to our specific program, which is going to be only classifying 4 classes. The variable layers is going to contain all the new layers we wish to train our network with, whereas the net variable has all the pre-existing layers. Hence, the 23rd layer is going to be a fully connected layer with the parameter 4, which implies 4 classes to be identified, and the 25th layer is going to be a classification layer. Let us run this code. We see that the net has 25 layers and the 23rd layer has an output size of 1000, whereas in our new 23rd layer, we see that the output size is 4. Coming back to our program, we create a variable called input size that is going to store the size of the input of the AlexNet network. Then we create a variable called all images that is going to store the image database that we have already created. Then we are going to split the database into training and validation set in the ratio 7:3. We make use of the split each label function to do so and store the training set in imds train variable and the validation set in imds validation variable. Then we create a variable called pixel range, which is a matrix that has the values -30 and 30, which is used in the image augmentation we are going to perform further. Image data augmentation is a technique that can be used to artificially expand the size of a training dataset by creating modified versions of images in the dataset. We then use the image data augmenter function to perform image augmentation and set the properties like randx reflection to true, randx translation with the value of pixel range, and similarly randy translation to have a value of pixel range and store it in image augmenter. We then perform data augmentation on the training data set and store it in aug-imds train. Similarly, we also just store the validation data set in aug-imds validation. We can specify the training options using the training options function and store it in a variable. The first option, which is a string SGDM, is an abbreviation of stochastic gradient descent with momentum, which is the solver name of our network. The maximum number of epochs is set to 4, which indicates the total number of passes through the entire training data set the network has completed. The initial learn rate has been set to 0.001 and it shuffles every epoch. The validation data is the aug-imds validation variable. The validation frequency is set to 3. Verbose is false, meaning that it won't be displayed in the command window, and we have chosen to plot the training progress. We can finally train the network using the train network function and pass the parameters of the aug-imds train, which is the training dataset, the layers and the options, and store it in the variable detector net, and we can also save this network. Let us now run this code. We can see from the accuracy graph the accuracy keeps on increasing with every new epoch. Also, we can see at the end of the program, we have achieved an accuracy of 100%, which we can further test. We can see that our network, detector net, has been saved as a mat file, which we will be using in the next program. This is the code to load and use the network we have just created to recognize faces. We use a while loop to continuously take images from the video stream. We create a camera object and store it in the variable cam. Then we use the snapshot property to continuously take images from the video stream and store it onto the variable pic. Then we use the face detector system object to create bounding boxes around the pic. Then, as we know, if sum of boxes is not 0, then face is present. We then crop the image according to the bounding boxes values. Then we resize it to the AlexNet input size. Then we try to match the detector net labels along with the image using the classify function. We then display the image and also we display the title. So these are the reference images of the people's faces we are going to recognize in our program. Let us finally test our program using our smartphone. Since the snapshot property is in manual mode, we have to manually click the photo. Now, if we go to the figure window, we see that the face of Donald Trump has been correctly recognized. We can do the same for the other faces as well. We see that J.K. Rowling has also been correctly identified. We see even Mark Zuckerberg has been correctly identified. And the last person to be recognized is myself, which we are going to do by using the front camera. To open the front camera, we have to pass an additional parameter called front to the camera function. We can see that the face recognition program recognized my face as well. This means it managed to recognize all the 4 faces accurately. It is evident that our program managed to have an accuracy of 100% due to the small number of classes. There is a scope for improvement in terms of recognizing multiple faces in a single frame. Face recognition algorithms are improving at a rapid pace due to the advancements in the field of artificial intelligence. We can deploy our program to make attendance systems in schools and colleges, smart surveillance cameras, etc. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments or get in touch with us. Follow us on LinkedIn, Facebook, and subscribe to our YouTube channel. Education is our future, MATLAB is our future. Happy MATLABing!